In this video, we're going to do a quick overview of chemical groups called functional groups. So for the most part, so far, what we've seen are the hydrocarbons, which are basically just carbon and hydrogen. And we've also seen alkyl halides, where you've added things like halogens to the hydrocarbons. So in organic chemistry, we can add groups to the hydrocarbons to give the hydrocarbons different properties. You might remember that hydrocarbons, because they're only carbon and hydrogen. So here's a simple one. They're very nonpolar. They're going to have their nonpolar molecule characteristics, typically lower boiling points because they only have London dispersion forces, for example. And low solubility in water because, well, they're very nonpolar and they won't be able to interact with the hydrogen bonding or dipole-dipole interactions of polar solvents. So what you can do is there's chemical groups that can be added to hydrocarbons to give the hydrocarbons different properties. And that's what a functional group is, a specific chemical group or group of atoms or bonds in a compound that gives the molecule specific chemical or physical properties. So, for example, one such group, here's a hydrocarbon. If I put an OH here, this is a functional group. It's a special group, an OH group, that makes the molecule more polar overall. So those different chemical groups found on your organic molecules are called functional groups, and they basically tell you what family or what class to put the organic compound into. If they're just straight up CH, they're just considered hydrocarbons. But as soon as we start adding special groups to them, special functional groups, then we can place the organic molecules into certain families. So for example, one functional group that we can add to the carbon chain is the hydroxyl group, the one I just mentioned here, this OH. And so to represent it with a formula, we would represent the carbon chain as R and then OH. So this whole thing would be R, and then it's connected to an OH. So R, OH, and this is called hydroxyl group. Typically, molecules that have the alcohol functional group, the hydroxyl functional group, are called alcohols. There's another functional group called the carbonyl group, and that's really just a C double bond O, a C double bond O. If you have the carbonyl group in the middle of a carbon chain, so for example, here's a carbon chain, not right in the middle, but and essentially not at the ends, so not here or here, but maybe somewhere here. When you put that carbonyl group somewhere there, you call it you call the molecule a ketone. A ketone. So if you have a carbonyl group, functional group, not at the ends of a molecule, that chemical class the molecule is part of is a ketone. If the carbonyl group, because it's the same thing here, if the carbonyl group is at the end of a molecule, so as you can see it over here, R, and then this is the terminal carbon, the last carbon. We have double bond O, and then there'd have to be an H there to make carbon have all its bonds. If the double bond O, the carbonyl group, is at the end of the carbon, of the carbon chain, then it'll be called an aldehyde instead. So here we have the formulas represented to show what that would look like in condensed form. So if you have an aldehyde, it's RCHO, which essentially means R, C double bond O with an H there. This one over here means R, C double bond O, and then the rest of the carbon chain. And this one simply means carbon chain connected to an OH. There are more functional groups. Another functional group is called the carboxyl group. The carboxyl group is, in a way to think about it, it's like it's a carbonyl group plus a hydroxyl group. So you have the double bond O on the carbon and then the OH. And you can represent it this way, R, C, double bond O, OH, just like this at the end of a molecule. If you see that functional group, your molecule is called a carboxylic acid. Another functional group you might sometimes see is the ether functional group that makes a molecule part of the ether class. So you'll just see it's essentially just an O that connects two carbon chains. So R, there's one chain, O in the middle there, and then R prime, there's another chain. And that would be the ether class of molecules. You might also have what's called the ester functional group. The ester functional group is very similar to the carboxylic acid one, except instead of having an H at the end there, you'll put another carbon chain. So you'll have carbon chain, carbon, double bond O, no H this time, but another carbon chain. So it's almost like you have two carbon chains connected by not just an O in the middle, not just by a carbonyl group, but by this C double bond O like that. And so this would make your molecule considered an ester. You might also have a carboxamide functional group. The carboxamide functional group is, so we have R, C double bond O, and then N, and then you have typically other things connected to it, two other things connected to your nitrogen. I'll just put two carbon chains, but it's really this C double bond O N group that's the carboxamide. And if you see that, you have an amide. So that's an amide now at this point, like this, with the double bond O connected to a C here, and then an N right next to it. Something that students often confuse with amides are the amines. Amines, their functional group is an amino functional group, or an amine functional group, you can call it, is typically NH2. And if you see this, simply an N attached to a carbon chain, so either an NH2 or sometimes it could be just an NH. It varies depending on the bonds that you have there. But if you see this nitrogen group without the double bond carbon there, it's simply a nitrogen group, then you have what's called an amine instead. And so here we have an amine. It kind of looks like ammonia when you think about it. You have three H's normally, except here we replaced one of the H's with a carbon group or a carbon chain, and we have an amine at this point. And so in this table, you can see examples of molecules that have those functional groups. So here we can see an OH, the hydroxyl functional group, which makes an alcohol, which we'll learn a name later on. It's called methanol. Here we can see the carbonyl group in sort of in between the chain, not at the ends. So this makes this a ketone molecule, and it's called butanone. Over here we have ethanol. You can see that we have the carbonyl group at the end of the molecule as opposed to somewhere in the middle. Here we have the ester, the carboxylic acid, the carboxyl group shown in the molecule, and so that's ethanoic acid. Over here we can see the ether functional group that makes this whole molecule over here an ether, ethoxyethane. Here we can see the ester functional group. So this is connecting the two carbon chains, and so we have ethyl butanoate, and we'll learn how to name those later on. Over here we can see the carboxamide functional group, the carbon, the N there, double bond O, making this an amide, so ethanamide. And then over here we can see simply the N, no C double bond O anywhere, and so this makes this an amine, and that's methanamine. Now the functional groups have a priority that you need to follow. So if you have multiple functional groups on a molecule, you have to decide, well, am I classifying it, for example, as an alcohol or as an ether or as an amide? So if you have multiple functional groups, what do you classify your molecule as? It's based on a order of priority set by IUPAC. So to find the order of priority, you can just go to your handout or go to your calendar, and you'll see a list over here. This is the priority list order. And so the highest priority is on top, and then we get lower and lower in priority as we go towards the bottom here. Just remember that for the most part, when it comes to side chain priorities, the aromatic phenyl group, the alkyl groups, the halogen groups, side chain wise, they were all basically the same. So do keep that in mind. But again, here you can see our priority list. Carboxylic acid takes the highest priority, followed by ester, amide, aldehyde, ketone, alcohol, amines, ethers, and then aromatic compounds, alkenes, alkynes, alkanes. and then haloalkanes. So you need to follow this priority list when you're trying to decide how to classify molecules, especially if you see multiple functional groups on a molecule. This will help you decide what to best classify it as. It doesn't mean the other functional groups are no longer important because they're still going to confer or give properties to the molecule. It just helps you decide what to best classify it as in that particular moment. So let's go and just do a few examples where we have to identify some functional groups and name them. You can see some examples done over here. Although I didn't list it in the previous table, the double bonds and triple bonds in a carbon chain, they do count as a functional group as well because they give chemical properties to the molecule. And then your phenyl or your benzene also counts as a functional group as well. And when your functional group is not the highest priority, you will treat it as a substituent. And when you treat them as a substituent, they'll have different names. So, for example, let's say OH was not the highest priority, so I didn't have an alcohol, but it was still there. Its prefix name would be hydroxy. A ketone, if that wasn't the highest priority, the prefix names would be keto or oxo. For aldehyde, the prefix name would be aldo. For the carboxylic acid, the prefix name would be carboxy. For ether, it would be alkoxy, an alkoxy group, instead of saying an alkyl group, for example. For the amide, it would be carboxamido, and then amino group for the amine if it's not the highest priority in the molecule. So, for example, let's just draw this out here. You don't know how to name this yet because you might not have seen the lesson yet, but this is an OH group, and over here I have an amino group. And so, oops, that should be 2. So I have to decide if this is going to be classified as an alcohol or an amine. And what I'll do is I'll go take a look at my list to see which one's higher up. And it looks like alcohol is higher up than amine, so that means the alcohol is going to win. I'm going to treat that molecule as an alcohol and name it as such. And the amine is going to be a side group, and so I'm going to call the side group amino. So when I name it as a substituent, so I'm going to start counting to give the lowest number, highest priority, in other words, to the alcohol. So 1, 2, 3, 4, 5. If I went the other direction, then the OH would be too high in number. So this is a pentanol molecule, but on carbon number 3, I have an amino group. So it's 3-amino pentanol. If I didn't have this OH here, then I would have this as an amine because there's no OH to take priority over it. So that's how that priority list works, and that's how the substituent name for each one works as well. So you should be able to identify functional groups in molecules if they're provided to you. You have terms provided to you here, and you need to classify each of the following based on the functional group and based on the class they'd be in. So we'll start with A. This is A over here. A is an OH group. We know that's hydroxyl. And if you have a hydroxyl group, typically it would make you an alcohol, assuming you have the highest priority there. Let's go with B. B, you'll notice, is a benzene group. You can call it phenyl as well. And that typically makes you an aromatic compound because compounds with benzene in them are called aromatic compounds. Here we have a simple nitrogen. It's not, the carbon next to it would have to have a double bond O for this to be an amide group. So it's not an amide group because it's not the carbon next to it that has a double bond O. So we're just going to make this an amino group. And that would make your molecule an amine for C. For D, we have a double bond O. This is a carbonyl group. And since it's in the middle like that, not at the end of a molecule, that molecule would be a ketone. For E, we have, it looks like one of those alkoxy groups, because just the O in the middle of a molecule, not double bonded. And so that would make your molecule an ether. And then for F, so this one's a bit tricky the way it's written out, but if you have one bond here, then one of them is an H. This has to be a double bond O. So this is a carbonyl group, but notice that it's at the end of a molecule, so it's still a carbonyl group, but it's at the end of a molecule. So rather than be a ketone, it would be an aldehyde. So there we have named several functional groups in this big molecule, and we said what the class would be if they were the highest priority one there. And then here you have similar problems that go over the same approach. So let's try this one together here as well. So for A, it is considered a functional group. That's simply a double bond. So there we have a double bond. And that double bond in a carbon-carbon chain, if this was the highest priority, would give you an alkene. For B, notice we have the double bond O with the N right next to it. This would be the carboxamide, which would give you an amide. For C, it looks like we have a carbonyl group. We have the C double bond O H. It's at the end of a molecule, so carbonyl, and that would make you an aldehyde. For D, it looks like we have just straight up nitrogen, so an amino group or an amine group, you can call it, which would make you an amine. There's actually another term for an amine in a ring, but we're not really going to see that this year. Here we have a carbonyl group for E, carbonyl, but it's in the middle of a chain, so that would make that a ketone. F's interesting. So F has basically a carbon like this, two O's. So to get your four bonds, you need one of the O's to be double bonded, the other O like that, and then CH3. So you have this group here connecting two carbon chains, essentially, the other carbon chain being the ring and the rest of the structure up there. So this looks like your ester group. That would make this molecule an ester. And then here, this is interesting. We have a carbon connected up there to another carbon. And to get the full bonds, we need a double bond O and then an OH here. And that would give us our functional group. This looks like a carboxyl functional group, which would give us a carboxylic acid. And I'm not sure if I named that one properly above, just in case I didn't. Carboxyl, this here, gives you your carboxylic acid. So there we've done a bunch of practice problems where we matched the functional group to the picture of the functional group to the name, and then we said what class of molecule you'd be if you were part of that. And so we can try just a couple others over here where we have to label this molecule in its functional groups. So here we have the benzene or phenyl functional group, which would make you aromatic. Here it looks like we have this double bond OH at the end. So this would be a carboxyl, and that would make you a carboxylic acid if it was the highest priority. Here we have a carboxamide, because you have the carbon double bond O and then the N next to it. This would make you an amide if you were the highest priority. And lastly, there's a great quiz you can try here online. You might not know the difference between the primary, secondary, and tertiary amines. But that's okay. You can still attempt this, and you can look this up if you want to ahead of time so you can get a preview and then attempt the quiz with a bit more knowledge. So in this video, we defined functional groups, saw various examples of functional groups, how to name them and how they classify substances. And we saw they have a priority you have to follow. We did examples of labeling functional groups and molecules and classifying what the molecule would be, assuming that that functional group had the highest priority there. So become familiar with these functional groups because you will need to know them, since we are going for the rest of the unit to take a look at all these special classes of molecules like alcohols, amines, amides, aldehydes, esters, and we have to recognize our functional groups to be able to identify them and then to name them.